So here we're going to find the perimeter of a complex shape, and our complex shape has a few different pieces to it. It has some portions from a rectangle, and it also has some portions from a triangle and a portion from a circle. And so what we need to realize is that this quarter of a circle is centered at the point C. And so we'll need to know a quarter of its circumference. That's going to be part of the perimeter. So for the perimeter, we are going to need to know the circumference of the circle. So we're going to need to know the perimeter of the circle, otherwise known as circumference. And the formula for that is C is equal to 2 pi r. Now, we also are going to need to know the radius, but it looks like this line segment, FB, and this line segment, EC, are the same. So it's a pretty good guess that our radius then is going to be 5. So our circumference is going to be 2 pi times 5, or 10 pi. And that's the circumference of the entire circle. So if we continue the circle all the way around. Okay, now we're going to need portions of the perimeter from the rectangle, so we'll just call it P rectangle. We're not going to use the full formula though. So we're just going to use the two portions that we need. So we need line segment BC and we need line segment FE. Now we know line segment FE is 2 meters, and because these are all right angles, because those two sides are the same length, we know that this is a rectangle, and those two sides then are the same length. So FE is equal to BC, which means we'll have 2 plus 2 being the perimeter portion from our rectangle. So it's not the whole perimeter, it's just part of it. And the last thing that we're going to need is we're going to need the portion from the triangle as well. So we'll call that P triangle. And that will be this hypotenuse portion, or root 40, and the line segment from A to B, and let's just call it S for short. So we need to find S. Now to find S, I know that it's a right triangle, so I can use the Pythagorean Theorem. So I'll set up the Pythagorean Theorem to find S right here. And so it'll be the hypotenuse, or C squared, is equal to A squared plus B squared. And now I can replace what I know, so this is the root of 40 squared is equal to A, let's just let A be our S squared, and B is going to end up being 25 because we're dealing with 5 squared. So now the root of 40 squared is 40, so if 40 equals S squared plus 25. Subtracting 25 from both sides gives me 15 is equal to S squared. And so then to find the value of S, I need to take the square root of both sides, and I'll get that S is equal to root 15. So now I can take that value of S and place it in here. So I'll have root of 40 plus the root of 15. And these portions are all the portions from root 15, root 40, 2, and 2. And then this 10 pi is all the way around. So I don't need the whole 10 pi, I just need a quarter of it. And then I also need to add in CD. But since this is a circle, this line segment is going to be the same as this one. Remember that this line segment was 5, this one was 5, so this will also be 5. So my perimeter in total is going to be a quarter of this 10 pi, because I have a quarter of the circle. The radius, because I have to add that portion. That radius was 5. The portion from my rectangle, which was 2 plus 2, or 4. And the portion from my triangle, which was the root 40 and the root 15. Now I just have to combine some like terms and reduce here. So 1/10 times a quarter is going to be 5 halves pi. 5 plus 4 is 9, so plus 9, plus root 40 plus root 15. And that is the perimeter of my triangle. Sorry, of my shape. I'll make a statement and I'm done.